Today we are looking at one-step equations, which most of us already know how to solve, but now we're going to apply some properties to them and explain why it works. So this is on page 40 of your journal, of your ISN. It's a window, 4-page window. Okay, looks like that. And I'm going to start with an example that I think will help illustrate this a little bit. So if I have an equation 5 plus 3 equal to 6 plus 2. We can all agree that this is a true statement because 5 plus 3 is 8, 6 plus 2 is 8, 8 is equal to 8. So this is an equation that's true. Okay? Our properties of equality, we have 4 of them: addition and property, subtraction, multiplication, and division. Just say that if I do a property to both sides of the equation, that my equation is still going to be true. So let's look at addition. If I add 4 to both sides of this equation, is it still true? Well, I have 8 plus 4, which is 12. 8 plus 4, yes, it's still true. Okay, so the addition property of equality just says I can add a number to both sides of the equation and my equation is still true. And we're going to take a look at how that works for subtraction, multiplication, and division. Now let's just take a look at something like 5 plus 3 plus negative 3 equal to 6 plus 2 plus negative 3. This is still the addition property of equality because I'm adding negative 3 to both sides. Okay? So I get 3 plus negative 3. This is my additive inverse, right? I get 0. So over here I get 5. Now I have 6 plus 2 plus negative 3. So 8 plus negative 3 is 5. My equation is still true. So what I did here is I added negative 3 in order to get rid of this 3, even though I don't have a positive 3 over here. I wanted to eliminate this 3. And you'll see that's why we do what we do when we solve equations. So let's take a look at how this works over here. I have an example. This is on page 39. Here's my example. X minus 5 is equal to 2. Now I'm going to add 5 to both sides of my equation. That's my addition property of equality. And I'm adding 5 so that I can get rid of this and I can isolate my variable x. So I add 5 to both sides. I have x plus 0, which is just x. That's the additive identity. And I added 5 over here. 2 plus 5 is 7. Now I want to make sure I check my solution by substituting 7 back in for x. 7 minus 5 is equal to 2, and that's what I got. So that's how I know that my solution, x equals 7, is correct. As you can see, I'm undoing this subtraction, and I'm undoing it by using addition. Okay, this is the addition property of equality, and you can see it right here, addition property of equality. Okay, so here's another way to look at that. I'm going to open up my window. Let's look at this example here. I've got x minus 3 is equal to 7. Well, I need to isolate the variable by itself. So in order to do that, I'm going to add 3 to both sides because it crosses this out, and I'm left with x. 7 plus 3 is 10. Now I'm going to plug it back in to check. Okay, I'm going to plug 10 back in for x. 10 minus 3 is equal to 7. That's true, so my solution is correct. Let's take a look at the subtraction property of equality, and I'm going to do that over here. Everybody knows how to solve this problem. X plus 8 equals 3. Now the subtraction property of equality just says I can subtract a value from both sides of the equal sign. And in order to eliminate or to isolate the variable on the left-hand side, I have to be strategic about what I'm subtracting. I'm going to subtract 8 from both sides. Notice it's in both sides. 8 minus 8, here's my additive inverse again. 8 minus 8 is 0, isolating my variable. 3 minus 8 is negative 5. Okay, they have different signs. I find the difference and use the sign of the bigger number. Now I have to plug it back into my equation in order to make sure that it's still a true statement. Negative 5 plus 8 is equal to 3, so my solution is correct. Down here, the tip is to undo the addition. So right here, to undo the addition, I use subtraction, my subtraction property. Let's look at what that looks like over here. My subtraction property of equality just says if A is equal to C, if I have some equation, I can subtract B from both sides and my statement is still true. Writing it vertically, I have x plus 5 is equal to 8. I'm going to subtract 5 from both sides and I get x is equal to 3. Okay? Let's try multiplication. Okay? Using the multiplication property of equality, we look at a problem like this. X divided by 7 equals negative 4. And I want to, again, isolate the variable on the left side of the equal sign by itself. In order to do that, I have to use the multiplication property of equality. What that says is I can multiply both sides by the same number. Why do I want to do that? Well, if I take x times 7, x divided by 7, times 7 over 1, okay? And I take negative 4 times 7. So I'm multiplying both sides by 7. My 7s are going to cross out. 7 divided by 7 is 1. Remember, this is the multiplicative inverse property. I'm left with x is equal to negative 28. I'm going to check my work. Negative 28 divided by 7 is indeed negative 4. Therefore, I'm correct. I'm undoing division by using multiplication. So that is this multiplication property of equality right here. Okay, so if I have A is equal to C, the multiplication property of equality says I can take and multiply both sides times B and it's still equal. Okay, another example would be maybe something like x divided by 4 is equal to 12. To solve for x, I would multiply both sides by 4. My 4's are going to cancel. Remember, this is the reciprocal of 4. This is the multiplicative inverse. My result is 1, or 1 times x. So x is equal to 12 times 4, which is 48. And if I plug this back in, 48 divided by 4 is in fact 12. So I know my solution is correct. Okay? Let's look at the division property of equality really quick. It follows the same thing. I can divide both sides by the same number. This also goes to the multiplicative inverse. And I'm going to divide by negative 4. Why am I going to divide by negative 4 here? Because a negative divided by a negative is a positive. So negative 4 divided by negative 4 is 1. 20 divided by negative 4. A positive divided by a negative is a negative. Again, to undo the multiplication, I'm dividing both sides by negative 4. So over here, division property of equality says this. I have an equation, A equal to C. The division property of equality says I can divide both sides by B as long as what? B is not equal to 0. So again, if I had something like 5x equal to negative 45, I would take 5x divided by 5, negative 45 divided by 5. 5 divided by 5 is 1. Negative 45 divided by 5, a negative divided by a positive is a negative, and I've got negative 9. When I plug it back in, 5 times negative 9 is negative 45. Okay, so those are our properties of equality. Let me zoom out here. Here's all 4 of them. Addition, subtraction, multiplication, and division. You can't see those. There we go, right there. Okay. Let's take a look, though, at this problem here. 2/3 x is equal to 12. Now, the hint down below is to get rid of a fraction that's in front of a number, we want to multiply by the reciprocal. This is the multiplicative inverse. And I'm going to highlight this a little bit. And I'm going to write a little note. Multiplicative inverse. A number times its reciprocal is equal to 1. Okay, so 2/3 x equal to 12. The multiplication property of equality says I can multiply both sides by the same number. In this case, I'm going to multiply by the reciprocal of 2/3. The reciprocal of 2/3 is 3/2, and I've got to multiply that by both sides. Now I know from the multiplicative inverse this is 1. This isolates my variable equal to x. Now I take 12 times 3 divided by 2, or I'm just going to quick simplify. Okay, I remember that this is also a fraction. I know that 2 goes into 12 6 times. 6 times 3 is 18. Now I've got to check my answer. So I'm going to plug this in up here with a red pen. 2/3 x, okay, now my x is 18. Is that equal to 12? Well, 3 goes into 18, 6 times, 2 times 6, 12 is equal to 12. There's my check. So when we do our one-step equations, I know you guys have done this before, but we are going to start applying these properties of equality and identifying what these properties of equality are. I'm sorry this video went longer than I wanted, but hopefully you understand those properties a little bit better.